Hey all, welcome to the video on permutations and combinations. We're going to start off with permutations. And permutation is a different arrangement of a group of items where the order matters. To understand this idea, we're going to go ahead and just jump right into some examples here. We have you and 19 of your friends have decided to form an internet marketing consulting firm. The group needs to choose 3 officers, a CEO, an operating manager, and a treasurer. And how many ways can those offices be filled? Well, in the first spot, let's say we're going to fill the CEO. And then we got the second spot, which is going to be our operating manager. Third spot, we have the treasurer. And so we got a total of 19 people at first that can be the CEO. We have 19 people to choose from. But once we picked the CEO, we only have 18 people. And then once we picked the operating manager and CEO, we have 17 people to choose from. And so if we want to know how many different arrangements are possible, we multiply all these together and we end up with 5,814 different ways. So how do I know that this is a permutation? Why does this represent a permutation? Well, because if Mr. R is picked as CEO, then if that position is moved to a different spot, then he's no longer CEO. And so the order in which the office positions are picked matters, because if you start rearranging, then you actually rearrange the position of the person. So let's look at another problem here, okay? I'm going to click and drag in this one here. We have a corporation has seven members on its board of directors. In how many different ways can it elect a president, vice president, secretary, and treasurer? So we want to pick a president, secretary, and treasurer. Alright, and so in the first spot we have a total of 7 different ways here. And then second spot we've already picked, so we have 6, and then we have 5, and then we have 4. So if we multiply all that together, we end up with 840 different ways that we can pick the president, vice president, secretary, and treasurer. And once again, this is a situation in which order matters, because if once you pick the presidential spot, if you flip-flop that person around, then that person's no longer president anymore. So this is a situation where order absolutely matters. Let's move on to the next one here. We have you need to arrange 7 of your favorite books on a small shelf. How many different ways can you arrange the books, assuming that the order of the books makes a difference to you? Alright, so first position, we have 7 different books to choose from. Second position, 6, 5, 4, 3, 2, and then last one, you got no other option but to put that book there. So if you multiply all these together, then you have 5,040 different options of arranging your books here, where order matters. Okay, so let's start talking about combinations. First, we need to distinguish between the two. A permutation is an ordered arrangement of a given group of items. A combination is a group of items taken without regard to their order. Permutation problems involve situations in which order matters. Combination problems involve situations in which the order of items makes no difference. To wrap our head around that one, let's say we have red dot, blue dot. How many different ways can we arrange red dot, blue dot? Well, according to permutations, we say, well, first position, we could choose red dot or blue dot. Then second position, we could have only red dot or blue dot. And then, so we multiply, we have two different ways that we could arrange these according to a permutation. So what's the other way? Well, we could arrange them so that we have blue dot and then red dot, right? So here are two different ways. Here are two different permutations. A combination says that the order doesn't matter. It just depends on what is within the set. So we have red dot, blue dot here, and we have red dot, blue dot here, and the order of arrangement makes no difference for a combination. So the combinations of red dot, blue dot are just one because the order makes no difference. Another way that you guys might make sense out of combinations versus permutations is with the lottery. Personally, I'd rather have a combination of numbers versus a permutation of numbers. Let's say we're playing the lotto, and you can only win with a permutation of specific numbers. And let's say that the winning numbers are 40, 30, and then 20. You can only win with those numbers. A combination says that the order of these numbers makes no difference. And so we could win with a 20 first, and then a 40 second, and then a 30 last. Combination sees no difference between these two arrangements because the order does not matter. Permutation says you have to have each one of these with a specific location. So let's go ahead and jump into some combination problems. But first of all, our bottom line is that permutations is when order matters, and then combinations is when order does not matter. So I got this situation here. We have part A, we have how many different permutations are there of ABC taken 2 letters at a time? How many different permutations are there of ABC taken 2 letters at a time? So let's think about this with numbers first. We're thinking about 2 different letters from ABC. So how many ways can we choose A, B, and C from for this first spot? There's 3 different letters. And then we go to the next spot here. How many different ways can we choose A, B, C for this second spot? Well, we've already picked one, so we only have 2 left, right? And so if we want to figure out all the different permutations there are of ABC taken 2 letters at a time, we multiply together and we get a 6. The visual of that is right here. We could have AB, AC, BA, BC, CA, and CB. So let's move on to combinations here. We have how many different combinations are there of ABC taken 2 letters at a time? Well, remember that combinations see no difference between the order. So that means that AB and BA have the same meaning as far as the combinations. So we're going to eliminate one of them. And CA and AC, there's no difference between those because it has the same exact letters within them. And then we have BC and CB. There's no difference between these two either because they have the same letters. So we cross off the duplicates there, and we see that we have 3 different combinations of ABC taken 2 letters at a time. So our magic number there for part B is 3, but how the heck do we get there? A combination is found by taking a permutation, so 3 times 2, and dividing by the number of ways in which we can arrange the repeats. And by the repeats, I'm talking about the 2 letters here. So how many ways can we arrange the 2 letters? That's just known as a 2 times a 1. So if we simplify here, we got 6 over 2, which is equal to a 3. So let's jump on. We got a combination. So a combination is a permutation divided by the number of ways the same set can be arranged. Let's get into some problems here. A 3-person committee is needed to study ways of improving public transportation. How many committees could be formed from 8 people on the Board of Supervisors? So, first of all, we have first position, you could have 8 different people fill that spot. Then the second spot, you got 7. Then the third spot, you only got 6 here, right? So if we multiply all these together, that's going to give us 336. The problem is that this is not a permutation, this is a combination. And how did I know it was a combination? Because if we have a committee of 3 people, if Mr. R is in this spot here, picked for the very first position, does it matter if he's moved to the second position? We're just talking about a committee of 3 people here. No, it doesn't matter at all. So, you know, Mr. R could be in the first, second, or third spot there, and it doesn't matter. The order of the committee members makes no difference. They all have equal positions within the committee. So we have to divide by the number of ways in which we can arrange the 3 people, which is 3 times 2 times 1, which is 6. And if we divide 336 by 6, we end up with 56 different ways. Let's look at another problem here. In poker, a person is dealt 5 cards from a standard 52 card deck. The order in which you are dealt the 5 cards does not matter. How many different 5-card poker hands are possible? So, this is an example of a combination, because when you have a hand of cards, the order doesn't matter. You could have 2, 3, 4, 5, 6, or 6, 5, 4, 3, 2, and that order does not matter. It just matters on your bottom line, what cards make up the hand that you have. So, how many different combinations of 5 cards can we make from a 52 card deck? That is going to be 52 times 51 times 50 times 49 times 48, which represents a permutation, but then we have to divide by the number of ways in which we can arrange 5 cards, which is 5 times 4 times 3 times 2 times 1, which gives us, let's see, over 300 billion, excuse me, divided by 60, which results in a total of 5,197,920. Okay, great. So we got lots of different options for our poker hand still, right? So let's end up with this one here. Count the number of different 9-letter words, and don't worry about whether they're in the dictionary, that can be formed using the letters in each word. So how many different ways can we arrange the letters in the word dragonfly? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we had 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that's going to be a pretty big number, right? Let's move on to butterfly. I'm running out of time here. How many different ways could we arrange the word butterfly? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Once again, the problem is for butterfly, you know, if you flip-flop the T's here, this is T1 and T2. If you flip-flop those T's, then you know, you still have the same word, right? So we don't want to double count that word. And so what we need to do is we need to divide by the number of ways in which we can arrange the letter T. And so that represents a 2 times a 1 there. All right. And let's move on to this last one here. Oops, the last one here. How many different ways can we arrange the word bumblebee? Well, bumblebee has one bee here, another bee here, another bee here. You could arrange the 1, 2, and the 3 differently and still have the same word. And we don't want to count that word more than once. We don't want to double count. So what we need to do for this one is we need to divide by the number of ways in which we can arrange the 3 b's, which is 3 times 2 times 1. We also need to divide by the way that we can arrange the 3 e's, so 3 times 2 times 1. And see you guys later.